Hi, and welcome to episode 4 of How Did You Get Data Lake? So last week we talked a little bit about Docker, and this week we're talking about serverless, which is both a concept and the name of a specific framework. So as you heard at the beginning, we also have an awesome new theme song. This was composed just for us by Shun Kobayashi. You should check out his website. It's cagpie.net. He has a link to his SoundCloud account and also some awesome JavaScript projects he's worked on under the development section. Check out especially Picotune, which is a chiptune, like it plays MIDI files in a chiptune style and has a piano roll visualization, and he wrote it from scratch in pure vanilla JavaScript. So that's pretty awesome, and thank you, Shun, for the awesome theme song. So let's get started. Hi, Sergio.
Hi, good morning.
So we just talked for about half an hour about what we should talk about serverless, and it's clearly a giant topic, and there are questions about, what. I think it's probably, let's just get started. Sergio, what is serverless?
Okay, let's keep it simple. I think that the own word is telling you what is serverless. It means like without servers, okay? This is a concept. It was defined by Martin Fowler in his wiki. And this concept has so many implications. And one of the biggest ones is that you don't have to manage anything. You have everything that is more a conglomerate of different services that they are link each other, and you don't have to own nothing about the platform. Okay, that's the concept. That's the big concept. Then there is some kind of feature, that, for example, it automatically scales. But you have, for example, this kind of functions. They are stateless. Okay, and yeah, this is the kind of concept. Okay, and from this concept, it appeared from some months, one year ago, I think, it appeared something that is called the serverless framework. Okay, and this serverless framework, they use the name serverless, okay, to have more kind of marketing. And these guys, they started with the first prototype that they focused the technology that is from AWS, that is Lambda. This Lambda, what happened when it appeared, it was the glue between the services. AWS, Amazon Web Services, they offer a lot of different services. And for send a request and process the request from one to another service, they create this Lambda that they present 2 years ago in the reInvent. Okay, with this Lambda, that is a service that led you to define a function. Okay, so you send an input, you process this function that can be in Node.js, in Python, in Java. You process the function and then you give back the result. Okay, so they create the Lambda. Well, the truth is that they already had Lambdas. They were using internally Lambdas. They create this service, and they create other service like the API gateway. Okay, so these guys of the YOS, before the serverless framework was called YOS,
right,
they said, this Lambda and API gateway, that's a perfect fit for create something that led us to create an API very fast without any server. Okay, so they start with the version 0, and they use CloudFront. They solve a kind of problems that they had with the environment variables, and they prepare a nice tool. But in the moment of the process, when they were learning, because everything that we are talking about is very, very new, okay, they are really on process, they discovered that they were not talking only about Lambdas and API gateway. They had to handle all of this. And all of this means not only Amazon, but it means the concept itself. That's why they changed the name. And right now, with the Lambda API gateway, because if we talk about Amazon, okay, let's focus in Amazon. I know that they have implementation for other services, but sometimes there are limitations. You can create a plugin to adapt them, but let's talk about Amazon.
Okay, let me, before we get any further, I want to back up to the basics, because so we've talked a little bit about what the idea of serverless is, and so that's lowercase s serverless. We've talked, and that's something that Martin Fowler has a really, really long blog post about. We've talked a little bit about the capital S serverless framework, which is an open source framework developed by a company that has venture capital funding that started, and it was originally called JAWS. Now it's called Serverless with capital S. We talked a little bit about Amazon's. So Amazon Web Services has a ton of services within it. So the most common services that you see are things like EC2, which lets you run virtual machines in the cloud. And then you have S3, which allows you to store objects and store data in the cloud. And then they have maybe 50 or 60 or 100 other services, but one of the most important of those is Lambdas, which let you run a function. And that function is run, it's written in, say, JavaScript, and it's run on Node.js, or it's written in Python, or it's written in Java. And when, for example, if something happens, that function is called. So that something happens could be something like you saved something to the S3 storage bucket, and so a Lambda function was called. Or with the API gateway service, you made an API call to Amazon, and then the API gateway service routed that call to a Lambda function. So does that sound right?
Yeah, perfectly.
Okay, good. So back to, so the other thing I wanted to talk about is, of course, there are servers. I mean, the code is getting run on servers, but what is different from the way code is run on servers via the serverless architecture versus a traditional architecture?
We have said the word server 20 times. I think
it's not serverless if you say server 20 times.
Yeah. We can use the word stateless, no? Say me again the question.
We can call it stateless.
Well, it's a property. The serverless has the property that this must be stateless. One of the problems, or when you are developing for a kind of serverless, that can be the serverless framework, is that you have to change your mind. You have to be very careful. When you are writing code, you don't have to write the code the same like you are writing in a container, for example, with the instance that is running Node.js. Because what happens is that because the code of the function is being re-executed several times, if there is a variable that is outside the kind of main function, okay, outside the scope, this function is not private like you thought. In a normal instance, it's going to happen. Okay, this in Node.js is using the common JS pattern, and if you have outside the main function, the exports, you have a function. This function is going to be private. In serverless, in Lambda, it isn't. It is shared by all the threads. So you have to be very careful how and when you load every component, okay, every file. When you do a require, you have to be careful if they are inside the function or they are outside, because this is gonna be the kind of state that is gonna maintain in the memory. And this is a concept that when you start writing code, you notice very fast, and sometimes you have unexpected problems. Okay, so
really, so multiple calls to lambdas could share state across calls.
Yes.
Really?
Yes. You don't really know when this is gonna happen. That's I mean, if you are sending several requests, maybe these requests they are always the same server, okay, the same instance that they have inside, because they are using containers. Okay, everything is by containers, so they are using like Docker to have the serverless thing. That's amazing. But you can send this request, and maybe all of them they are pre-cache, or maybe all of them they go to different servers. Okay, so you don't know. When you are writing code, you don't have to expect that they have to do. So one keyword that is very important for the serverless when you are writing serverless, or let's say lambdas, okay, because to be clear, when you are writing lambdas, is that it must be idempotent. Okay, that's very important. Yes, you can be able to re-execute something, and it has to do the same output than before. Okay, you execute this twice, and this should give you the same output. This is not easy, okay, and you have to be careful. But
okay, so actually, let's explore those two words a little bit more. We have stateless and we have idempotent, and
well, this is a property, okay? Just don't be confused. It's something that you must do to create kind of stateless lambdas, okay? You have to be careful about that. The most important component, I think, or kind of feature, skill, I don't know how to say that, but the function that you are writing must be serverless. And you have to be very careful when you are writing the function, because maybe you have problems or several requests at the same time for atomicity with the database. If you are from different servers, a same request, you can have a race condition to the server where you are modifying read and write the value, and maybe you are in the kind of period, you are sending two requests at the same time, and the result is unexpected. Okay, that's the thing, and that's what I mean with saying that is idempotent, is that you have to write this in the way that you are sure that running this again, or before, after, what you got is what you expect. Okay, so this is something that you must be thinking about when you are writing the code, because this kind of errors doesn't happen very often, and if you have few requests, you are not going to notice, but this can have a lot of security implications. Okay, because I could be making two requests in concurrent and in parallel, and they could do something that you don't really want to happen. Okay, and because we are talking about Lambda, that is a service that can be requested several times, and you don't have the control about this part. Okay, just be careful. Okay, you must develop some kind of Redis cache, memcache, something that will be able to tell you, hey, I am processing a request that is doing the same that the previous one. So be careful that this is going to happen. For example, Stripe.
Oh, so this is something to prevent race condition. So having like a Redis cache is to like prevent race conditions, or
we could say that this is one of the features. Okay, not the only one, but yes, this is gonna prevent. For example, Stripe, they develop something. Well, it's amazing. That is a idempotency, and you send a value that is unique. And if you send the same value in the next 24 hours, okay, they have a cache that is gonna tell you that, oh, we already processed this request, and the output is the same. So they are gonna send you back the same output that they already processed. So if you want to charge a user twice, you won't charge the user twice. You will only charge one. Okay, so the second time is only giving you back the response of the other. So these kind of interesting things I'm talking about, you have to be careful when you start writing code in Lambda. That doesn't happen when you are writing in your Apache server or something in your machine. The paradigm is different. Okay, so when you start writing in serverless, or even you are in a Docker architecture, you have to be careful, which the context has changed. Okay, that's it. So let's focus in your question and your.
Right. No, so I mean, if you're writing code to run on a traditional server, you might expect that process to be long-lived. So you have a long-lived, like 5 or 10 minute session with the user, and all the user's interactions are going to be routed to the same process. And so any request that the user makes to that process will probably be done in sequence. Whereas if you have lambdas that are just functions being run, if you're that could be run on the same server or could be run on different servers, and could get run out of order, you end up in a situation where you could have one request going to a Lambda running on one server, another request going to, or say the same request going to a Lambda on a different server. And so then you have two Lambdas trying to access your database, for example, and potentially returning different results. And so so you're saying that this you could either use a Redis cache or something like this Stripe. What is it?
Idempotency.
Idempotency to prevent, for example, two functions trying to run at the same time and do the exact same thing.
Yes. Let me give another example, okay? Because I think this topic is very, very interesting. Is this about serverless, okay? About Lambda and all the kind of plugins, triggers, connections, Lambda especially, okay? It's the same that when we change the way of writing code, when we were writing code for a kind of Apache, it was multi-thread, and we were writing multi-thread programming. So we had a core, and this has different threads, and we said, okay, let's create a new thread to do this kind of job, okay, in the background. So it's the same kind that every connection, he has his own thread. So we have a max of threads for requests. And then this architecture, when we change to the mono-thread architecture, for example, Node.js has like a loop that is is a ticker that when you send a request is the same process who is handling everything. Node.js has a space of memory that he's kind of virtualizing all the pool, okay? That is all the output that he receives. So because he doesn't use the function of the kernel, he is able to archive faster speed. So the same kind, different, how can I say, the same change of mind we had from this multi-thread architecture to the mono-thread, we are having to the kind of serverless. Okay, so this difference is happening again. Okay, so you have to be aware of your context. It's the same that when you are writing code for a phone, you know that the battery is limited, so you cannot do a long polling because it's consuming a lot of network, input, output, battery. Okay, so these kind of things, you must understand the context, and serverless and Lambda especially has a context. Right now they are improving a lot. We have new features. For example, we can use VPCs, we can use KMS, we can use environment variables, but you need to learn. There is a process to learn. Okay, the question maybe is, okay, once you have learned this, it's interesting to learn this kind of first stage to later use serverless and lambdas, or it's not worth and it's better to stay in some kind of container PaaS platform like Heroku or something like that. No? It's in the middle.
Yeah, so actually I think that the analogy you were making there is that is to multi-threaded programming, where if you have multiple threads running within one process and they're trying to access the same memory at the same time, you can run into all kinds of problems because you have, for example, two threads trying to access the same bit of memory at the same time. And now what we're talking about with Lambdas is instead of having multiple threads within one process accessing shared memory space, we have multiple Lambdas running on top. I mean, instead of one process, our process is now all of AWS. And we have potentially, instead of two threads running, we have two Lambdas running at the same time. I thought that was a really interesting analogy.
Yeah, that's right. But if we go deeper, you realize that you can do this because Amazon has so many servers, so he doesn't even care. What he does is they buy a huge machine and they split by cores, by CPU time. So because they already developed this kind of huge system that is able to give you a quote of, so it's a time in this CPU. So you can, for example, when you have a EC2 instance, a micro, you have just one slide of this machine. So it's time. Because they have these resources, they can do that. In the past, we used multi-threading because it was our own machine and was the most simple way to that. There is a word that I really love, that is commodity. And I think that serverless is a commodity. I think that it's something that you don't have to, as I said before, you don't have to care about the support. No, you don't need an engineer who has to handle the servers, deployments. Well, that's free. Well, it's not free. You are paying a price because, as I said, they can have this amount of things. But that's amazing. One of the problems, and I think I know about this, one of the problems about the multi-thread architecture is not that it's slower than a mono-thread architecture. The problem is that it's more complex. You need to care a lot of variables, logs, semaphores, a lot of kind of things that in the mono-thread architecture you don't have to worry about. So now with the serverless, it's happening the same. You don't have to worry about. And this means that you can hire a junior guy for writing functions in serverless that before with Java and with logs and with everything we had 20 years, 10 years ago, it was like not possible. You needed some very skilled guy who cared about all the things in his head. And now everything become easier, no? And that's a very good thing. I think that's a very good thing, and that's how we are going. And this is the future. In the last reInvent, they said serverless is the future, and I believe so. but maybe it happens in 15 years. No, it's not now. Right now we are starting. There are so many things happening, but we're gonna in the future. I guess that's my own opinion. That I guess that we are gonna be very heavy serverless and even more. We're gonna have a startup who offers a SDK, so we are gonna be more like kind of a Stripe. You don't care about what is over there. I just connect Stripe with my platform. That my own platform can be a conglomerate of other services, and that's it. So I think we are going to this kind of direction. Right now, we are reinvent the well a lot. It's still a lot, but it is going to happen. Who knows? Who knows? But I think so.
All right. So I'm going to link to the Stack Overflow. The Stack Overflow question, lock, mutex, semaphore, what's the difference? So, because I think those are three words that you just threw out there. I think also we find, I think we're 20 minutes in, but we did finally get to it, which is I think the fundamental difference between traditional architectures and serverless is that you don't manage the infrastructure at all with serverless.
That's right.
So you give functions, you give functions to the cloud, and you don't know whether Amazon is spinning up 1 container, 100 containers, or 1,000,000 containers. You just know that Amazon has responded to however many requests you've sent them.
Yeah. I will say, and I would like to make it clear that the kind of how we are billing in this process is completely different, and I think that's very, very interesting from the marketing side, because it make it easier for the developers and for the business people who are starting something. So if you have few users, you are gonna be billed only for what you use, so it's few. But when you start growing, you are paying more, but it should mean that you are getting more money. But that concept, I think, is very interesting. I still don't know so much, but the kind of billing, how you are charged, I think is a very good strategy from the kind of marketing guys for making it more expensive, even when it is cheaper for you and it's better for them, but they are earning more money with that. So it's wow, that's amazing. I think that is.
Right. So it's in a sense it might be cheaper for you because you are literally paying for exactly the amount of compute time that you're using. So instead of, so if it's like $19.99 and you're buying physical servers and you want to support a website that has 1 million users, maybe you've spent like $10 million on servers, and then they just have to sit there all year long when you don't get any hits, and then they're just busy on Christmas Day or something. Then in more modern systems, maybe you scale up and down the number of VMs. So you scale up and down the number of EC2 instances that you use, so that during the day, we have a lot of users streaming Netflix at whatever time during the day, so they have a ton of VMs started up at that time of the day. But then they shut down the VMs, at like 4 a.m., so there aren't that many running. And with serverless, you're literally using exactly the amount of compute time you need and no more. So as a business, it's better because you don't have any excess, you're not wasting any excess capacity. But is it still cheaper? It might. But it could actually, in some sense. I mean, first, it's hard to know what the prices mean because it's hard to compare. Like, it's easy to know how much it costs to run like 20 virtual machines with these specs for a month, but it's very hard to know how many Lambda invocations an application will have.
Yes, one thing I want to mention also about talking about the billing is if we have to decide if we want to use Docker or serverless, I think that one of the biggest things is your business strategy is like the guests or the users, are they paying for the service or not? Because if you have something that is free, for example, that is you're giving free service for millions of users. Maybe if you use something like Docker, okay, or just your own machines, there is a limit, no? It's like you are paying this for the machines, and in the moment that you cannot handle more requests or more petitions, CPU, whatever, you are gonna be just queue them, or you are gonna give a timeout, so just try later. That's it. This is, as you said, this is what you are paying. If you don't establish any kind of auto-scale policy, that's it. You pay that. You can start a new one, but you know the cost. In the kind of serverless, if they start making a distribution attack over the time, and for example all night, and they are making requests to your platform because they want to hurt you somehow, you are gonna have a big bill at the end of the month. We have to say that Lambda, for example, is cheap, okay? And if you use API gateway, you can enable some functions for caching. So the guys of Amazon, they are really caring about the developer, okay? That they are not doing everything just to get money. They get money, but they are preparing everything for be very easy. I will ask you, Maurice, if you create a new company, would you start using serverless or Docker?
Okay, well.
You are not prepared.
Okay, no, I'm definitely the wrong person to ask, but you've made a very convincing argument for serverless, and specifically, with my own personal experience of trying to orchestrate Docker containers, that was a lot of time spent trying to just get containers running. Where with serverless, you really don't have to think about it at all. Like if I want to simply make a REST API and never worry about infrastructure at all, serverless does seem like a good option.
I think that maybe in the past you were using a very first version of Docker, but right now you have ECS, so you can deploy containers without caring of the instances. He's gonna create for you, and even you can use the fleet spot instances, so they are gonna be very cheap. It's really good. Okay, you can prepare something very nice. I think that the problem, as I said before, the serverless, maybe is you need to learn a new concept, a new kind of development, but going inside what is the serverless framework, okay, talking about this, I love it. I think that the last version, they did an amazing job. They really understood what they needed. They understood the concept, and that's amazing. And why it's amazing, let me say, it's because you only have one file. In one file that is called serverless.yml, you have everything. You don't have dependencies to anything else. If you don't want to use tomorrow the serverless framework, you stop immediately. That's over. You will use another platform. You can use them you create new plugins and you connect to your own serverless provider. So you don't have to worry at all. But it is amazing to have one file, and this is the full dependency. Wow, that's amazing. Later, if you use Amazon, you can use CloudFormation to deploy everything, other dependency. You can set all the triggers. That's amazing. For example, they also, and I would like to mention that, is maybe in another chapter we can talk more about this, is that they divide your accounts, or they force you to divide the accounts. They want that you will deploy in one AWS account for test, one AWS account for staging, and one for production. They don't really want you to do all of them in one place. So this is very interesting, because we are saying that an employee, maybe he has access to 2 accounts, but not to production. So it's very difficult for them to do RM and remove everything. Okay.
Okay. So right now, the first maybe 25 minutes of this podcast, we were actually talking about lowercase serverless, so lowercase serverless in a sense, and Amazon Lambdas. And now what we're talking about is the capital S serverless framework.
Yes, let's say serverless framework, because sometimes the capital is something that when you are writing the GitHub repo, you don't have.
Okay, so tell me more about the serverless framework. Like, what is it? Like, why do we not just use Amazon Lambdas directly?
Well, because at the end, it makes you easier to have all the services. It let you, for example, set all the triggers between the functions. I mean, what serverless framework make you easier is to make everything automatic through code. You can write this file, as I said, serverless.yml. From this file, you can load other files, so you don't have to have everything 4 million of lines in one file, but you can split in different files. And with a very simple syntax and semantics, that is YML, you can define everything you need. VPCs, you can define variables, you can set the environment variables that they are different, okay? The variables is the custom variables that they have. You can set that you allow only the framework from the version 1 to the version 2. You can do everything just through code. In your own project, you can have this file and with the client, okay, that's important. You need two components, okay, for the serverless framework. You need to install globally the serverless, that is the own tool, and then you need this file. That is, if we say like a circle CI GML, no, that is telling you the instructions. So when you execute serverless deploy, he's gonna find this file and he's gonna follow the instructions that you gave, no, with all the variables and all this stuff. You can say you can establish that every function is independent, or you can say that every function is related with the global variables. That's very interesting because this serverless framework, I think that it makes you to work by project. So when you are doing something like image process project, you can have everything in one place. So you share the code. Okay. What else can we say about the serverless framework?
So, I mean, I listened to this podcast on Software Engineering Daily with Austin Collins, who's the founder of the framework. So we'll definitely link to that podcast. And I think the way he sort of described it was, when you're setting up Lambda functions one by one, at some point you end up with so many Lambda, like you end up with this giant pile of functions. Like if you're writing if you're trying to replace a monolithic application with a series of Lambda functions, you could end up with a large number of functions that repeat lots of code within the functions. And what the serverless framework is trying to do is it's trying to give you a structure for architecting an application using things like Lambda. Does that sound right?
Yeah, in some way, I think I don't agree completely, because if you go to the functions, you're gonna realize that there are millions of functions, and as I said, right now they are not reusing the alias. So what is happening is for every function, for every stage, they have one function. So if you are sharing all your accounts, you're gonna have huge amount of functions over there. So I don't think that they are solving the problem about, don't use so many functions. Okay, we are saying that because every function he needs to pre-start, so it means he needs to load everything into memory. It takes more time to execute the first function. The next time is going to be pre-cache. Okay, so I think that how can I say?
Well, what do you see? Like for you, what makes you so excited about the serverless architecture? Like, what do you think is the best part of the serverless framework?
I think, as I was saying, you don't really want to look Amazon. You don't want to look at the dashboard. You want to have in one place all your code, and in the moment that you deploy, this kind of serverless is going to be the interface. You don't even need to go to the dashboard to look at the graphs. You can do serverless stats or info, and you can see what is happening. You can get the logs from CloudWatch to get the information. You don't need to go there and see that you have 1,000 functions. You have in your code, and the code is being split in several files, and you organize as you want. Okay, and if you use API Gateway, as I said, with the serverless framework, they are very together. What is the best or what I like of this framework? I really hate the framework in the first version because they change so many times. Right now I think they are more stable, but right now I think that they have understand, and maybe it's not this point that you are mentioning about, oh, we don't have so many lambda. No, we have so many. They have, but that's happened. That's not gonna be a void. They are just making this easier, and this easier through code. And code that, as they were using previously JSON, and now they are using GML. And believe me, when the users are using GML, you feel that it's easier to read.
This is YAML, YAML.
That's it. And Amazon is making you easier to use now GML. Before they had everything with JSON. Right now you can do GML, and you can use some alias for some functions to, for example, refer attribute of something. In CloudFormation it's being used quite. So I think that we are using serverless framework because, one, we decide to use for some microservices some lambdas. Okay, that's very interesting. That's, as I said, if you create every microservice is one project, that fits very well. And the second is that you don't really want to handle this directly. You want to use something that help you, and as you said, it just create a structure for you. I think that's quite enough. No, later you are, when you are learning about the building, about how the kind of power it led you to have this kind of resources that is the CloudFormation. After all, with CloudFormation you can deploy everything you want. You can deploy SQS. Every service that you have available in Amazon, you can deploy with the serverless framework. You can do that. So it's not only Lambda. And now it's amazing. They create another service that is called Step Functions, and this service, it fits very well with the Lambda. It is the same like single workflow something, SWF, okay? And this service before, you needed to create so many, you need a lot of workers as a EC2 instance. Right now with the Step Functions, you only need to create a JSON file, and this JSON file is going to make the flow of your business. For example, the first step is to download this file from wherever. So you call this Step Functions, he calls to a Lambda, and he waits until you get the result of the Lambda. And when he gets the result of the Lambda, he continues. But if there is an error, you can handle the error. If you get a result, you can do a choice for select which path do you want to follow. So you have like a tree or like a graph. You have a graph of the different process that you have your own application, and you can write everything with JSON. So it's very similar to what we are having with the serverless framework. No, all of this. You can write code, and this code is going to be translated into services of Amazon. And there is a moment that, well, you remember, and I love this topic. Before we had the sysadmin. This guy, he was looking at some statistics. And now we have the guy who is the DevOps. And what did this change? Because the DevOps is a guy who is a programmer. And he's programming the code for making everything automatically. You don't need to wait and look at the statistics, graphs, whatever. You just need to make the code that if there is a problem, please send me an alert, send me a message into a Slack, into my phone, into wherever you want, that I'm going to notice and say, okay, now I have to do something manual. I need to fix, and the first thing I'm going to do is, one, create a test, and second, make it, well, fix it, of course, and make it automatic. And the next time it happens, you have something. It's being auto-handled, whatever. So this kind of weird changing that is in parallel what I said before about a commodity. This is what is happening in the kind of computers.
Right. So that there's less operations and less administration, and it's much more what computers are good at, ultimately, automation.
You can pay a very, very cheap price for having a lot of things that before it was so expensive.
Yeah. I wanted to talk a little bit about microservice architecture patterns for Lambda. So how do you I mean, so step functions are one Amazon service for dealing with business logic, where for tying together, for example, a bunch of different Amazon services, including Lambdas. So you, as you described, you can have a step function that starts with a file, sends it to a Lambda. The Lambda does something based on the results of that. Then the step function decides what to do.
Mm-hmm.
How do we architect large? I mean, how do we architect larger applications with many different functions on top of something like the serverless architecture?
Well, that's a very difficult question, because at the end, as I said, always is the purpose, the requirements. I don't even have a response. No, I think that these tools it helps. No, but that's the truth. In the moment that you start doing a project that is huge project, you have to split. You have to split the project, and I think in this guy Martin Fowler, he talking about the monolithic architecture. He tell you that you have to be very careful. Don't pre-optimize your platform. If you start with a small company and you have a kind of limited bucket, maybe it's interesting to start with something like Ruby on Rails. You start growing, and in the moment that you have more people, you notice what the people they are asking, what is the kind of service that you are using. You want to have a public API. It's in that moment that you have to start extracting this kind of monolithic and huge app into different microservices. You have to be careful, okay? If you are a bank and you have a mainframe that is huge, that's a huge problem. You have to migrate this somehow. That is not. Sometimes you don't even know, okay? But that's because they start from so many years ago, and they have a lot of depth, okay, technical depth. But other companies like Facebook, they don't have these problems, and they handle more data than some banks, okay. So I think that when we are talking about this kind of big platforms, I don't have the solution. Even talk that, I have, or for example, you start a new project and you say, I want to do everything with functions, with everything we are talking about, serverless framework. I think you have to be very careful. And I recommend that you should have a little bit of experience working with this, because right now I have been working with serverless for a while, and I know the kind of problems that they expect. And this, well, when you are writing the code, you are already thinking about this. And not only, well, I am a collaborator of the serverless framework, so it means that I know a little bit the code, okay? I have read the code.
You made some spelling corrections in the reading file, I think.
Yeah, a couple of things, but I have been really reading the internal things. They rewrote completely the code. They were using the last version of Node.js for making everything more readable and more for maintain the code. So going back to the question, okay, how do you do a big thing? Maybe you can start working with some microservice, and this microservice is just a serverless framework thing. But yeah, I recommend to do everything in progression, at least right now. Maybe 15 years later, everybody is using this kind of serverless structure. They don't have even sysops, or they have only a SDK that they print all the statistics for you, and that's over. So yeah, I cannot tell you, because maybe you are using something that you need a graph database, and this doesn't fit with the functions, because I don't know, there is sometimes that you make a request that is more than 5 minutes, no? And right now there are the implementation has this limitation. So I think it depends. It depends. You have to know a lot about a lot of things, and the more experience you have, the better it's gonna be.
Yeah.
I don't have a response. I don't have the silver bullet.
Yeah. Yeah. As you were describing that, I was just thinking of, sometimes like people who are new to programming or new to programming on servers are kind of overwhelmed with how many technologies there are, and just trying to figure out like what is the best technology, like what is the best framework, what is the best everything. And there's really no answer to that, because of course it depends on what your skill level and where you and what you're trying to accomplish. But I was thinking, actually, in some senses, it's if you have like a monolithic Ruby on Rails app that you've already developed, sometimes once you've had if you're starting as a programmer without a lot of experience, I would still say go to Ruby on Rails as a way to learn about what a server-side architecture can look like. Then once you understand that, maybe you're just an individual and maybe you can build everything that you want on that. But if you do get big, it's very easy to break up a Ruby on Rails application from a monolithic application into a bunch of microservices once you understand what the monolithic application you're trying to create is. Does that sound reasonable to you?
Yeah, I think it's reasonable. I have a couple of things to say. One is that we are talking about Ruby on Rails, but you can choose another kind of framework that helps you to write all this and I think that it's important when you start using this kind of framework to try to discover what is happening inside, because that's the important thing. We have, for example, in Python, if I remember correctly, this is called Tornado, that is give you like a framework like Node.js. So you have in Python. Okay, in Python, you have the same that you have in Node.js. I think that we don't have, or for example, you can use Laravel, that is for PHP. There are so many frameworks that they are enterprise level, or you can use Phoenix, Elixir. I don't mean about the tool, no? I mean that when you start with one of them, try to read a lot what is happening in the internal, no? All of these frameworks, they have very, very talented people, and they have documentation. So what I recommend is that try to understand very well the framework before start writing the code, because later you discover so many disappointing problems, and you are gonna this is gonna happen. Okay, so you are not gonna avoid that process. So just have the error and okay, how can I solve it? But I think that the most important is, or I recommend, that to start using one of them. And yeah, maybe what you mentioned, the second point, is that you are talking about business and you are mixing with technology, okay? And I think that that's different. If the business side, they are a startup and they don't know what they are selling or where they go, that's very common. But this is a business problem. If you are writing a code and you want to do this, you can write in every language you want. What you have to care is about the design, the architecture, what is happening, who is making a call, where, how. For example, and it's also, well, that's the main goal, is you want to write your code for being able to modify later, to extend, and you want to be able to change some parts and don't have to modify everything, no? That's the purpose of all the kind of coding, okay? You want to make it individual parts, and the problem is sometimes you get like, how can I say, tired of writing so many helpers, not helpers, okay, but we don't have to write helpers, but we have to split, no, everything. And when you split everything so many times, you write the test, and the business side, they ask you for changing everything again, and you have to modify the test. Okay, this is gonna be very stable. That's nice. That's how you have to write the code. But if the business side is telling you every 3 days to change everything, believe me, you don't want to write the test because you are gonna have to change everything, and then they don't have. They are gonna impose your deadline. So you don't want to work like this. You want to say, okay, guys, please research what you want, and this project is gonna you are gonna say the estimation of time. You are gonna say them, hey, please, this is gonna take 3 months plus 1 month of QA, for example, and then we're gonna release 4 months. So your decision is worth 1 million, for example. The architecture is gonna be 100,000, okay, dollars, for example, and the implementation is gonna be 10,000. So with this in mind, that every step in the business side is gonna be expensive, you have to be very careful when you take a decision.
Say that again. Go. So yeah. The decision is $1 million.
Yes, yes. I mean, you have to see this like a tree, as an inverse tree. That means that when you take a decision, if you take a bad decision, this is gonna cost this is an example, like $1 million. If you decide a wrong architecture, a wrong design, the big picture of your technical side, this is gonna cost $100,000. Okay, so it's like one magnitude less. And then if you make implementation detail that is not worth and you have to change, this is gonna be 10,000. Okay, so I am talking about this is another level of kind of money that you have to pay for that. So one mistake in the decision is gonna be terrible for a company. One mistake in the kind of implementation of one library, that's fine. You can change the library, that's all. In the moment that you have tools like New Relic, you can check all the kind of flows, where is the transactions, the database, you can check everything so you can improve the function. There is always a law that is like 80%, the 20% of the code is taking the 80% of the time. So you just have to discover that and make this more performance. Okay, that's the idea. So when you were saying like, oh, but if they make you change, well, maybe we have to talk about the business side, but let's go again to the technical side.
All right, so I think we should start wrapping up, but what about communities? I see you have something in the notes about which community is better. Docker, serverless. What do you mean here?
Yeah, well, as I said before, I have been a contributor in not Docker, okay? These guys, they use Go, and I still don't know very well Go. I have been reading the code, so I knew a little bit. I have been following the issues, and I know a little bit about, as I said, well, I have been also following the newspaper that you can subscribe. It's amazing. They select
the Docker newsletter?
Yes, the Docker newsletter. That's amazing. They tell you about the last kind of tools, for example, for the UI, how you can deploy with Swarm, with Docker Compose, how you can do, for example, one Go application in one Docker container. So that's very easy to deploy, and it's amazing. Okay, so I know a little bit about the kind of GitHub, the issues. I don't know more than this, but I have read, for example, the forums of the serverless framework and the issues, all of this. And I think, from my point of view, okay, and international kind of feeling, okay, because I think that we should talk more about the international to make this more what happens in every country. So I have the feeling they are different. It's not better. They don't have better community. It's just, they are different approaches, okay? Both of them, they have the same, okay? They are this. I mean, they use the same tactics, but I think that, for example, Docker, they got investment. They got a huge investment. I think that 1 billion. I don't remember, or maybe it was worth 1 million, but they have a lot of money behind. And these guys, they took several guys from big companies, and these guys, they are amazing. And I know personally about the security side. They got some guys that they really worry about. They prepare a lot of things, well, a lot of features that they are related with the security. So I will say that Docker, they really care about getting stars. Okay, they also care about a lot of the image. For example, I don't want to be like partial. Okay, I want to be very impartial, but I think that it matters. Okay, talking about the marketing side, but it's like, okay, that's the appearance. But I think that this happen more in Docker. They go to this way of thing, so they go very nice guys, well, amazing people, smart people, and it's very good. It's very good. And then serverless, I think that, at least from my point of view, they really care a lot about the community. The community gave a lot of feedback because this is so beta. That's why I am a contributor, because even I did very few, I am list over there, no, and I have mentioned like, oh, thank you for this, no, and this is stupid, and I love how they manage, because they thank you all the time, and to so many people. They don't even they didn't care about to give credits to you because you give only one line. But every time you push something, you make a pull request, they are strict what they want. So you must to have tests, you have to be sure that you don't break nothing, you explain everything you did, you have some kind so I think that the policy for that is very, very strict. But it's, well, that right now what we have is an amazing product. It's going to be better with the time, but right now it's very stable because they solved all the problems that they had, and they didn't how can I say, release something before they were right, or they knew that it was the right way to solve the problem. I remember the discussion with the environment variables. It was terrible. Okay, they spent so many months just to decide how to do that, and at the end, what happened is that AWS Lambda, they allow to have environment variables. Okay, so they prefer to wait to a real solution, and believe me, right now the solution is very good. They prefer to wait until this than to create some kind of patch, because they did, okay, with the version 0, with the first release, with the beta, they did mistakes, but that was normal. And well, these guys of we have to mention that these guys of the serverless framework, they have been founded by Amazon, okay, so but yeah, these guys, I like how they handle, but both of them, okay. I'm not saying that one is better than the other. I think that both platforms, they really have very, very, very good people. In the Docker side, for example, I know that in the network there were some issues with the network. It was failing a lot in version 0.5, and I remember that the guys, well, at the end they said, okay, off, let's rewrite everything, and they start to write what is now the kind of Docker network, and well, it's working now. So maybe we need to wait a bit longer, some years, even some years, to be these things like something like main, no, a stream. Like, it's not trending anymore. This is what you start using, no? But I think, and this is a topic we talked about before, I think is necessary. If you are starting to write code, you are a junior developer, I think it's very interesting if you start reading the history, no, of all of this, because everything has a meaning because something happened. They solve a problem,
I mean, when I was listening to this interview yesterday with Austin Collins, he talked a little bit about trying to create a really good open source community, and that was sort of the pre 1.0 focus for serverless was definitely on creating community. And it sounds like, based on your experience, they did a really good job of that.
Yes. Really.
Cool. Okay. Any final thoughts? Any other things you want to that we haven't covered yet?
No. I think we have to be careful with this. I think that if you invest in serverless or even Docker, let's talk about, I think that you must be careful, because you know that you are going to spend time solving problems, because
they're still relatively young as frameworks.
Yeah, that's it. But I really like it. I think that you should, at least, even you should read the kind of pages for serverless architecture for Martin Flower. So I recommend that you at least know about a little bit, even you don't work in the DevOps thing. It's the same that, for example, the guys in the backend, they need to learn about the last technologies, a little bit about AngularJS, React. We need to know what is the paradigm, but because in the moment that, for example, Facebook, they release something new like GraphML, and the people in the front end, they want to start using because it's easier, whatever. You need to adapt to give them what they want. No? So we are not working alone. We are a team, and if something is changing very fast, you have to be up to that. No, so right now this about serverless is something that is hidden. But maybe it's not so hidden as we think about. If you use API Gateway, maybe it's faster, but believe me, a Lambda is going to take between 100 milliseconds and or more, okay? And
which is kind of slow.
Yeah. It depends the settings that you prepare, so this is going to cost you more. And Lambda, let's say that it's a bit slow, okay? It's not going to be so fast as you can prepare in a container architecture, okay? Or a normal, what we understand as normal right now, or trending, or what is the mainstream, no? Mainstream. So, I think so. Yeah. Let's see what happens.
Yeah, and so, a little bit of that is like, it's like container startup, like the cold start cost of Lambda. Yeah.
Do you want to talk about this?
I mean, I think that's a whole other topic of how to actually, because in theory, you do have all these Lambdas running and you don't actually ever have to worry about, I mean, the theory is that you never have to worry about how many containers are running, et cetera, but in practice, there is a tiny, and even if it's only like 100 or 200 milliseconds, there is a cold start cost on serverless architectures. So you can't completely forget about the infrastructure, but perhaps the benefits of mostly being able to forget about the infrastructure are worth it.
Yeah. Let me mention something just to finish this topic. It's about how it works. Is that they have internally containers. So when you ask for when you want to execute the Lambda for the first time, what they do is that they start the container for you. So you have this start, the cold start, and in the moment that this is on, they keep the container for 30 seconds. If in 30 seconds you haven't do any other request, this is gonna be off. And that's it. Okay. If you make another request in this period of time, then they are gonna reuse the same container that is the same Lambda that is gonna be executed again with everything in memory. So at the end, internally, they are creating these containers. Don't confuse. Okay. I don't think so. I don't know this, but I don't think that they are using Docker. I think they have a custom solution. As I said before, these guys, Amazon, from the start, or not the start, okay, because the start is 20 years ago, but from some years ago, they are using Lambda and step functions internally. Okay, so everything that they use is using Lambda. So I think these guys, they have a custom version, and this version, and I'm sure, is just copying memory. It's just, okay, please, I have this function, please copy in the memory. Okay, I have 1 gigabyte of memory. My function is 100 megabytes, so it means that I can have 10 functions at the same time. So I have one of the functions is one function that is a cron, and this cron is checking all the time what is active and inactive. And in the moment that you discover that there is one that is more than this time, you remove from this memory and you copy the function from the memory to that side. So what they mean talking about this memory is that it's very fast, it's very performance.
Right. It's just to copying memory.
That's it.
All right. Well, if you have any questions or feedback, we probably will have a Twitter account next week, and you can always at either me or Sergio directly. So great. Talk to you next week.
Okay. See you.
Bye-bye.